Here's the clicker, and Cameron is doing the switch right now.
Thank you, Jeff, for that very kind introduction. Your check is in the mail.
Perfect.
Some of it was even true, and that's pretty cool. He asked me to be brief, but I am an attorney, and so that means my number one credo is never use one word when two will suffice. But we'll try to be brief. I don't think it's not at the beginning. How do we get it to the beginning? While we're doing that, just briefly, for those of you who may not know, I'm pretty sure most of you know what the NTSB is, but we are the accident investigators. We investigate accidents in all modes of transportation. You see us a lot in aviation. We were just on TV last week for looking at the Asiana crash in San Francisco, but we also do railroads and major highway accidents and maritime, and the reason we're here now is because we also do pipelines. So that's what we do, and our main output is recommendations, and we do it with a focus on safety. So since we are not a regulator, the media would have you believe that because we issue recommendations, we can't require anybody to do anything. The media would have you believe that people just trash them, say this is just a recommendation, but in reality, they do it more than 80% of the time, even though it's not required. And to me, that's a tribute to our permanent staff like John Vorderbruggen, who's here in the audience. That's why it's an honor and a privilege for me to be there to work with such world-class staff, because that means two things. One is they are world-class investigators to find out what really happened, what went wrong, and two, they are world-class analysts to look at that investigation and make recommendations to try to prevent it from happening again. So we are here because of a recommendation that we made. So I'm going to talk about that SMS recommendation, and I'm also going to talk about an example, because the best example I have, although it's not at an organizational level, it's at an industry-wide level, but I would submit to you that this industry-level success story is transferable to the organizational level pipeline operators in terms of a way to implement SMS. Because this model, the word SMS, the whole concept SMS never really entered the room, but yet it does exhibit all the characteristics of the SMS. So it's going to be an aviation success story. Then after that, I want to close with talking about some of the external issues external to the operator, namely the role of the regulator. The regulator has to be on board with this, and they obviously are, and also the role of the manufacturer of the equipment that you use. They also need to have a process that feeds into this. So first, we're here because of the Enbridge pipeline event in Marshall, Michigan, and we issued the report in 2012, and our probable cause talked about a lot of organizational problems that the company had. And that's the reason we're here. And then one of our findings was this situation would significantly benefit by the implementation of a safety management system. So that was it. One of our recommendations to API was to convene a group to look at developing safety management systems for your operators. So that's the reason we're here, and kudos to you guys for being here and for doing this recommendation. We can issue recommendations till we're blue in the face, but what gets us excited is when people actually do what we say, and that's why I say they do it more than 80% of the time, so we're really pleased with that. But what you did is actually a collaborative model of what I'm going to talk about, and kudos to you for doing it in a collaborative way, because we found that that's usually successful when you're dealing with complex systems. Now, again, back to the aviation model, the complex systems, and I'm sure that your industry shares a lot of this, because I don't claim to be an expert in your industry, and I'm not going to say one size fits all, but I am going to say there's a lot that could be learned from this success story and I think a lot of it is transferable to your industry as well. So starting with the context is it's a very complex system of subsystems that are interconnected, and because they're interconnected, then if you make a change in one subsystem, you have impacts throughout the other subsystems. So in our case, and in yours I think as well, it's a large, complex, interactive system, often tightly coupled, and new technologies all the time, so we're always on a learning curve. And that means we can never sort of rest on our laurels, okay, we figured that one out, because we're always on a learning curve with the new technologies. So in that environment, what we find is the safety issues typically are not because of one of the subsystems, but they're because of the interactions between the subsystems. So that's kind of good news, bad news. The good news is these systems are so robust that one thing rarely hurts anybody, but the bad news is they're so complicated that it's very difficult to point to a place and say, if we just intervene right there, we will stop this from happening again. So that's the good news and the bad news. In that situation, what we see is when it gets more complicated, then it increases the likelihood of human error in three ways. First, just because it's more difficult to design it without making it error-prone. Second, because the operators, the people at the pointy end of the spear, as James Reason would say, are more likely to run into situations that even the designers didn't anticipate. And third, the people who make the rules and regulations and the processes and procedures, likewise, a lot of things they don't anticipate either. And so the operators that you have who have good employees who are well-trained, seasoned, proud professionals, And they say, well, if I do it the way the rule says, oh, that'll accomplish this, but if I do it this way, I can do it better, faster, cheaper. And so they're deviating from the rule because their experience shows them that they can do it better, faster, cheaper. So the question is, when things go right, you say, oh, Joe, that was great, you did a wonderful job. When things go wrong, you say, hey, wait a minute, you didn't follow the rules. But when people don't follow the rules because they're trying to do it better, faster, cheaper, the question is, how do you handle that situation? Do you punish them for not following the rules, or do you say, wonder if there's a reason why they're not following the rule, like maybe the rule wasn't quite right for this situation. And that's what we find is if you've got good people who aren't following the rules, there's probably a reason for that, especially if it's been happening for a long time with different people, same rule, different people, and they're not following the rule. There's probably a good reason for that, and the good reason is probably because the rule itself needs to be revisited because it doesn't quite fit the situation, and that's why your good people who know a way to do it better, faster, cheaper, do it better, faster, cheaper. So those are what happens when things get more complicated, more likely to, less easy to make it error-free, more likely to have operators encounter unanticipated situation, and more likely to have people do it differently than the rules say. And the result is that your frontline staff, who's highly trained, competent, proud professionals, are still committing error. And that's the key to it. Every industry I talk to, and I talked to lots of them because when I was at the FAA, many industries came to the FAA and said, how are you guys managing risk as well as you do? So that's, as a result of that, I'm talking to nuclear power and chemical manufacturing and petroleum refining and banks and healthcare and lots of different industries. Even a school board came to me to talk to them. I said, what? I don't get it. And they said, well, you try to stop plane crashes. Our plane crashes when someone drops out in the 9th grade. Wow, that's an interesting notion. So they've had lots of, I'm finding out that this is much more generic than I ever knew. And that's the exciting part, and what made me realize how generic it was when I started down this path was a report from the Institute of Medicine in 1999 that estimated somewhere between 44,000 and 98,000 people die every year in U.S. hospitals due to medical error. Wow, so when I read that report, you read that and you replace operating room with airplane and doctor with pilot, it looked just like us. And that's when I realized that we're inventing the same wheel. So that's when I started reaching out to other industries, and they started coming to me, and that's the reason I'm speaking to so many industries. And every one of them, I say, like I said to you, I am not an expert in your industry. I don't pretend to be, so I'm not saying one size fits all, but I am saying there's a lot that we can learn. So the solution is system think. How do you understand what's going to happen in these other subsystems when you make a change in this subsystem? The way they did it in aviation was system think via collaboration, and that's why I kudos to you guys for collaborating, because the collaboration means bring everybody who's got a dog in the fight together so that collectively they can do 4 things. 1 is identify what the problems are. 2 is prioritize the issues, because you're going to find more things than you have resources to fix. So you need to decide what's going to be front burner and what's going to be back burner. Number 3 is you put some implementations in place for the ones that you put on the front burner. And then 4 is evaluate whether those implementations are A, doing what they're supposed to do, and B, not doing what they're not supposed to do. So that's the collaborative effort, and it's been a huge, huge success story, and there was a real catalyst for it in aviation. This didn't just happen because some people sat down and said collaboration is a good idea. There was a real catalyst, and the catalyst was that their fatal accident rate had been coming down wonderfully for a whole bunch of years until the early 90s, and it started to get stuck. So for example, introduction of jet engines, they're so much more reliable than piston engines. That caused a quantum drop in the fatal accident rate. Introduction of simulators. So now the pilots can practice stuff in the simulator you never want to do in a real airplane. So if they ever actually see it in a real airplane, okay, been there, done that, then they know what to do. So lots of reasons why that rate was coming down, but then it was starting to get stuck. So meanwhile, the FAA is projecting double of the volume of flying in the next 15 or 20 years. So the aviation marketing folks in the aviation world are saying, wow, that's kind of scary, because flat rate times double volume, simple arithmetic tells you your aunt in Peoria is going to be seeing twice as many smoking holes on CNN. And your aunt in Peoria is not interested in, don't worry, the rate's low. Your aunt in Peoria is counting the number of events, and that's what scared them in aviation, to say, we got to do this different, because do the Einstein thing, you keep doing what you've been doing, you're going to keep getting what you've been getting. And what we were getting so far is a flat, stuck rate. So that's what started, that was their catalyst to start something they had never done before, which was collaboration. So basically what it meant was changing the way they think from, we put a lot of money in training you, and if you had absorbed the training, you wouldn't have messed up. So apparently you weren't careful enough, and that means it's time for punishment. So that's what they would always do. Something goes wrong, somebody gets punished, okay, took care of that problem. Well, you didn't take care of that problem because the people are human and humans make mistakes. What does that mean? That means we need to look at why people are making mistakes. Two aspects of that. Why did the system allow the mistake? And two is, why couldn't the system accommodate the mistake without catastrophic consequence, and then see what we can do to improve the system. So this was a huge shift in thinking from punish, punish, punish to, wow, let's see if we can fix the system and figure out why these good, highly trained, competent, proud professionals are making mistakes. And in the case of pilots, they're making mistakes that can kill themselves. As they say, the pilots are the first to arrive at the scene of the crash, and that's not where they want to be. So there was a real big red flag waving here that why are these people making mistakes, and these mistakes can kill themselves. So if a person is tripping over the step X times out of 1,000, you have to ask, is it because the person is clumsy? What is the problem? Is it because the person is clumsy, or is the problem the step? So should we just say, be careful at the step, or should we do more than that? Should we paint it? Should we light it? Should, in other words, what is the real problem here? Is it the person or the step? Well, the real problem is actually the interaction between the person and the step, and that's where we're coming from. Is it's not the system, it's not the person, it's the interaction between the person and the system that we have to try to understand. The way we have to try to understand that interaction is by collecting and analyzing and sharing data. So that's the fuel for the process, is data. That's the stuff that's happening every day that's going right, that's going wrong. That's the fuel for this process. And the objective of the process is very simple: make the system less likely to cause error in the first place, and if it does cause error, make it more able to tolerate the error. So what was the result of this collaborative process in aviation? After that stuck flat rate, they started this collaboration. In less than 10 years, they reduced that flat, stuck fatal accident rate by 83%. And that was pretty amazing because they used system think and they fueled it with that information from proactive information programs. And guess what? They proved not only safety, but they improved productivity. And that just flew in the face of conventional wisdom, which says if you improve productivity, you're going to hurt safety, and vice versa. They improved both of them at the same time. So I have a theory about that. My theory is I'm at the table, I'm collaborating, I'm here to talk about safety, but I'm not even going to put an idea on the table if it hurts my productivity, because I know what my productivity is and I know what's going to hurt my productivity. That's something the regulatory process can never do, can never really account for productivity the way that collaboration can. And that's why, and I'm not surprised to hear Jeff say there were some highly spirited meetings at first, because these people have very different interests, and that's why, oops, did I, oh, okay, this is basically talking about the collaborative process and how they brought the airlines and the manufacturers and the air traffic organization, the pilots, everybody, the regulator, together to identify, prioritize, solve, and evaluate. So the moral of the story is if you're involved in the problem, you need to be involved in the solution. That's very simple. So I'm trying to find out, okay, there it is. Why have I not ever seen this at an industry-wide level before or since? Because it's very difficult to do. This is not natural. This collaboration is not natural. The old model is the regulator says, I'm in charge here, and here's the problem I see, and you guys need to fix this problem by doing X. So they put out a notice of proposed rulemaking. Everybody responds to the notice. So the regulator hears what A thinks, and they hear what B thinks, they hear what C thinks, hear what D thinks, but A never finds out what B and C and D think. And the regulator is not privy to any of that, A and B and C and D trying to understand each other's perspective. So what happens is, regulator does this, everybody doesn't like it, they say, FAA, you don't fly airplanes, you don't understand airplanes, and I don't like your identification of the problem, and frankly, your solution is horrible. It'll reduce my productivity, it really won't hurt my safety, et cetera, I'm going to fight it, I'm going to litigate it, do everything I can not to do it, and to the extent I absolutely have to do it, I'm going to do it minimally and begrudgingly. So that's the adversarial, typical regulatory process. Collaboration is night and day different, because now, by the time something exits that process, everybody is on board with it, because everybody's involved with identifying the problem, so everybody's got buy-in because they helped develop it. And so that means they're going to promptly and willingly implement it, and not only that, but I can guarantee you that if it's a complex system, the first one that comes out of the box is not going to be quite right, it's going to need some tweaking. And so because everybody's got an ownership interest in it, they're going to want to tweak it to make it work better. That never happens in a regulatory context. So the solution's better, it's more effective, it's more efficient, and very much, it's highly unlikely, given that collaborative participation, to have unintended consequences. Let me add another one, another footnote to this. They did this whole thing, this 83% improvement in 10 years, without a single regulation. No new regulation. When I made that statement to the American Banking Association after the meltdown of '08, and they're facing a flood of regulations, they gave me a standing ovation. Wow, no new regulations. So this is a win for the government too, because now, as a regulator, they're actually accomplishing the improvement of the risk management improvement without new regulations. They're doing it because the people want to do it, because they're doing it through this collaborative program. So why is this so challenging? Well, first you start with human nature. Human nature says, I'm fine, you're not. I don't need to go to the marriage counselor, you go to the marriage counselor. Okay? So everybody comes in, so the manufacturer says, oh, hey, I built the airplane great. If the pilots would just fly it right and the airlines would maintain it right, we wouldn't have a problem. And the airline says, if they would just build the airplane right and the pilots would fly it right, we wouldn't have a problem. And the regulator, of course, the regulator says, if you just follow the regulations, we wouldn't have a problem. So everybody says, my stuff is okay, you got to get your act together. So getting people past that is no small feat. They often have, they are very likely to have differing interests, but also likely to have not only differing, but competing interests. So labor and management, they have competing interests. In the Asiana crash, I can guarantee you one of the defendants is going to be the airline and one of the defendants is going to be the manufacturer. So they're going to be beating up on each other in court, but yet we're asking them to come and play in the sandbox together in this collaborative process. So that's a huge challenge. Then the regulator, nobody wants the regulator there. I'm not about to bare my soul in front of the regulator, so nobody wants him there. And by the way, the regulator doesn't want to be there because they say, wait a minute, hold it, time out. That smells like a democracy to me. This cannot be a democracy. The law says I'm in charge here, so don't give me this democracy stuff. Well, it really isn't a democracy. What it is an information sharing process that enables everybody to understand everybody's perspectives, including the regulator, and enables improvements without, in our case, the need for new regulations. And it was a huge win-win, but it only happened when people realize in their enlightened self-interest that it can be a win-win if they stop their myopic, protect my self-comfort zone, and start thinking about how the system can improve so that we can all improve. So that was a huge, huge challenge. And that, to me, is the only reason I can figure out why I have never seen this collaborative concept before or since in any other industry. And the linchpin of this is trust. So that's why it takes so long to build. That's why they had heated arguments at first until they started realizing, hey, you know what? We have a common objective here. There's no point in us beating up on each other. We have a common goal here. And so let's take that as a starting point and use that as a way to get moving and develop the trust. So that means it takes a long time to build, easy to destroy. Trust is tough. So question is, I gave you an industry level example. Can it apply at an operator level? And I would submit it can apply at any micro or macro level at which you define a problem that you have with a system that's not working, even down to the workplace level. I would submit that this process can be used for workplace safety as well. It can be used at any micro or macro level that you define that you have a problem, get a collaborative effort around that problem and solve it. So I would submit, yes, it does. I would submit that it would work at an operator level. Now, having said that, the beauty of this process is it has all the elements that I saw in the draft safety management system document, but they never did use the term safety management system in this entire process when it was underway. But yet you will see that every element that's in there is in this process. So that's a great thing, and that's why I'm submitting this to you as a way to do it, not the way to do it, but a way to implement 1173. Now, here's some external factors. First of all, the regulator's got to be on board with this because, as I said, the fuel for this process is information. And if the regulator doesn't define very carefully how this information will be protected, then people will not provide it because they're afraid they're going to lose their job if they provide it. So the regulator has to emphasize the importance of system issues in addition to, not instead of, but in addition to worker issues, because nothing that I've said is get home free, get out of jail free for the worker, because the worker is always, always, always ultimately accountable. So I'm not talking about don't look at the worker. I'm talking about look at the worker who is always accountable, and also the system in which this proud, highly trained, competent professional is trying to do their thing. So it's worker plus system. It's not system instead of worker. Encourage and participate in industry-wide system think, and right now I'm hearing that the regulator is participating in it, and kudos for the regulator for participating in this collaborative effort. But here's the key, as I said, the information is very sensitive, and who's got the ultimate control in most industries over the protection of the information? The regulator does. So if the regulator doesn't clearly announce the protections for that information, then the people on the front lines who know it, live it, and breathe it every day and have that information will not put that information into the system because they're afraid for their own job. So that's a crucial role by the regulator in order for people to have safety management systems at the operator level. And last but not least, the regulator, if the regulator views that their goal is how many people can I punish, then we got a problem here. But if the regulator views that their role is how can we improve the management of risk in this system, then that's a very different goal. And And what I'm hearing from Jeff is they have recognized that their goal is not how many people can we punish, and that's a tough one for them, because when they go to Congress and say, give me more money, and Congress says, why should I give you more money? If the answer is so I can punish more people, well, that's easy to measure, that's an easy answer to give, but what the answer ought to be is, so I can improve the management of risk in this industry. But that's a tough one to measure and a tough one to go to Congress and say, look at how well we've managed the risk, more money, we can manage the risk better. So, you know, my sympathies to the industry for how they can do this, because their easy metric is how many people do we punish? Their more difficult metric is how is the risk management in our industry? Another external factor is the manufacturer, because the manufacturer, if they don't engage the end user in making what they make, then there's a problem by the time you get the equipment as the purchaser of the equipment. So let me tell you again, using the aviation example, what happened there. The manufacturers used to just put the airplanes out there, and the pilots would say, pilots are the end users, they would say, I don't like this, I don't like that. Some of the manufacturers said, wow, we could probably make a better airplane if we brought the end users in to help us design it. So they bring in the end users to be consultants. Early in the design phase, you have to wonder when you get some of these software upgrades, you say, did anybody ever really use this thing? Because I want to do the outline this way, but it won't let me because it's going to make the outline go that way. Have you ever had that happen where you and the software don't agree? You have to wonder, did they ever really have a real body use this stuff? Well, that's what they did. That's what the manufacturers did. They said, let's bring the end users, the pilots, and have them help us with the design. Okay, number two, the airplane in order to be economically viable, it has to last for 40 or 50 years, which means it better be maintainable. So the example I use is, if you take your car to get spark plugs changed, which you have to do every 10 or 12,000 miles, and the mechanic says, oh yeah, sure, I can do that, but I have to take the engine out because it fits so tight, I can't get to the spark plugs. I have to take the engine out of your car in order to replace the spark plugs. So what a horrible design that would be, not only because it's hugely inefficient to have to remove the engine every 10 or 12,000 miles to do a known replacement function, but not only that, it's also, look at all the opportunities for error that introduces when you have to take the engine out just to replace the spark plug. So they bring the mechanics in early on in the design phase to make sure the airplane is very maintainable. Number three, this airplane has to fit in the system of air traffic controllers, and the air traffic controller is going to ask it to do a lot of things. And most of the time, the airplane is on automatic pilot. So that means if the automatic pilot can't easily do what the air traffic controllers typically will ask it to do, then there's probably, the airplane does not fit in the system. There's a misfit. And so they bring in the air traffic controllers early on in the design phase to make the airplane fit in the system. So these manufacturers have looked at friendliness at three levels: user friendliness, maintenance friendliness, and system friendliness. And I ask you, how much of that do you see with your manufacturers? I mean, it may be happening out there. I may just not know about it, but to me, the equipment that you get by the time you see it should have gone through a process like this in order for the manufacturers to make sure that it suits the needs for which it is made. So that's the other external factor. One is the regulator, and two is the manufacturer to help as supplementary aspects of successful safety management system. So a properly structured collaborative safety improvement process includes all of those elements. I'm not saying it's the only way to do it, but I'm saying it is a way to do it, and I ask you to look at that in terms of figuring out how to implement a safety management system in your own organization. The industry-level collaborative success story, I think, is a model for an organizational level collaborative success model. And the regulator plays a key role because they are the ones who define the protection of the information, and the manufacturers play a key role because they are the ones who provide the stuff you work with all the time that has to fit comfortably within that system in order for a safety management system to be successful. So thanks again for the opportunity to be here. I don't know how much time we have left, but I'd be happy if we have time to take any questions you might have. Thank you.
Thank you, Chris. Chris has graciously agreed to take any questions, so I welcome those of you who are here and also those of you on the webcast. As I said, I gave you the address earlier. I think it's pipelineforum@dot.gov, right? Anyone recall, Darius? pipelineforum@dot.gov. Feel free, and we have someone monitoring that email address. So anyone have a question here for Chris? Linda? Yes, and I'd just like to ask everybody who does step up to the mic, please tell us who you are and your association.
I'm apparently very short.
Linda, you don't count because you've heard this before. No,
Well,
just kidding.
Yeah, but I have a new question. So I'm Linda Darty. I work for PHMSA Office of Pipeline Safety. Actually, I work for Jeff. But here's my question, Chris. You talk talked early on about the need to get a variety of people involved, and the success of the FAA model is because so many people were involved. They were collaborative and engaged and developed a good product, and they implemented it. What I struggle with is the idea that the people that you see in this room or the people that are watching us on the webcast from the industry or other regulatory groups are engaged. I worry about the people who aren't engaged, because at this point, you know, we aren't looking at a regulation. We're looking at a good process, a good safety standard that people would voluntarily implement. How do we get to those folks that aren't engaged, that say, it's not a regulation, I'm not going to worry about it. I got a good safety record right now. I don't need to do anything more. How do we reach those people? And how did the FAA folks do?
So that's a good question. How do we get to the people who aren't engaged? The engagement in our industry, we have a lot of public attention whenever anything slightly goes wrong. So an airplane can go off the end of the runway, everybody gets off the slide, sprains a few ankles, and it's national media. 35,000 people die a year on the highways, and nobody really hears about it. So we have a huge impetus in terms of the national attention that we get, which was the incentive for a lot of people to participate. Now, we also have a lot of players, but in situations where we have a lot of players, they participated through their trade associations, not individually, but through their trade associations. So the airline, for example, participated through its trade association. The manufacturers, the big airplane manufacturers, there were only two of them, Airbus and Boeing, so they participated directly. Then there were the unions, and they participated. So the idea in having that level of participation is, first of all, that was the vast, vast majority of the carriers of passengers in the U.S., so that covered most of them, but there were still those people, those outliers that you're talking about. Two things on that. One is the intention there was to show what an amazing success this could be, and then let people who weren't participating say, wow, that's really good news, I can participate in that too. And number two is, when we showed it was sustainable, because we safety people hate to say that if it hurts the bottom line, if this safety program hurts the bottom line, it's probably not sustainable. But unfortunately, if it hurts the bottom line, it's not sustainable. This is sustainable and has lasted since the mid-90s because it does improve productivity at the same time. So showing it's a success story and that it's a success story that improves the bottom line is what starts to bring in, slowly but surely, the latecomers. So it's basically the snowball that builds on itself. But that's a very good question, and getting that core started, and that's why sometimes when people have a tough time thinking of how am I going to get this process started, I recommend taking a beta test on something that's been your worst burr under the saddle for years and years. Like if it's workplace safety, what's been a workplace safety problem you've had for years and years and years? You've tried this fix, you've tried that fix, the other fix, still a burr under the saddle, and take your worst nightmare and do a beta test, a collaborative beta test around that. Bring all the players together who have a dog in the fight, and if that's successful, that's going to be, instead of just me talking, that's now going to be an experiential example of how successful this can be, and that then grows on itself. So that's what I suggest when I don't suggest most people start at an industry level like they did in aviation. I suggest a crawl, walk, run, and the crawl would be some micro situation, do a beta test around a micro situation.
Okay, other questions? Shelley, feel free to just raise your hand if you see anything coming in from the webcast. I wonder if I can ask one, since I hadn't made a lot of notes as you were talking. I could probably go on this forever, but one of the topics that the committee wrestled with was the role of culture in safety. And I know Chris is a thought leader in a lot of areas, and we've talked about safety culture before. It's been an important facet of attention for the NTSB. So I just wondered if we could get your quick thoughts on the role of culture and how does that serve the goal of safety or zero incidents?
Well, that's a fair question, because again, that's another term that was not mentioned in this process, safety culture. But the fact that these people got together and realized they had a need and that they could actually produce a win-win by getting together, that in itself was a manifestation of a safety culture amongst those groups that were doing it. But you never heard the term safety culture as such. So I'm not sure that's a direct answer to your question, except to say, again, we had that impetus that we get so much media that we don't want. Anytime we get media, it's because it's bad news, and so that was our impetus. And so it wasn't really somebody saying, I have a safety culture, instead it was somebody saying very practically, I don't want a crash, because another reality in our industry that I haven't seen in other industries is that everybody's crash is my crash, because the public doesn't think, oh, that was such and such airline, therefore I'm not going to fly in them, but I'm going to fly in the others. But the public perception is that was an airplane, and I'm about to get on an airplane. And so like when I saw BP Horizon, from my experience in aviation, when I saw BP Horizon, I said, oh, this is just a matter of time before I see all those other companies show up and say, you know, this was an industry accident, this wasn't a BP accident, this was an industry accident, and therefore I'm going to contribute bodies to help with this cleanup. Didn't see a soul, nary a soul. And that really shocked me about how different our industry is, because our industry views even non-US, I mean, the Asiana accident, or an accident in Russia, or in China, India, that's national, that's an international media, and the general view in our industry is everybody's accident is my accident, so we all need to work together. So that's not sort of safety culture as such, but it's just the fear of the bad publicity, if you will. And, you know, I was just shocked that all those other oil companies didn't come forth and say, this is an industry problem, and we are going to contribute bodies to help with this massive cleanup. So that's one of the reasons I say, okay, maybe one size doesn't fit all, because I know all industries don't share that characteristic, obviously, because I saw it with BP Horizon. But nonetheless, I think there's a lot that can be learned, and a lot of this process that is transferable.
Great. I know we have one other question over here. Maybe while you're standing up there, I'd just say I'd love to, and I bet we could explore for a long time this whole business about how do people react to accidents and how do their enlightened self-interest, because oftentimes what I find when we're having discussions with people is we're not aligned on the goal. You know, the goal was performance of the system, right? But a lot of people will be obsessed with compliance as the goal. And there are a lot of problems with obsessing on compliance as the goal. You know, as we all know, that is a negotiated outcome, you know, oftentimes, and it's a litigated outcome. So there are a lot of drivers in that world, you know, whether it's the Congress, as you mentioned, or others who are calling for blood. And I suspect after Deepwater Horizon, there was a lot of that. So everybody retreats to their corner. So quite interesting. At any rate, I recognize Stacy Gerard, who's come, a member of the committee and my former boss, who loves this stuff, so she stays engaged. Stacy, I know you had a question.
Right. Chris, I wanted to drill down a little bit more on the subject of human error and the problem of deviance from rules. And you talked about the mixed messages that leaders can send when they go, great, productivity's up, and however you're doing it, keep it up. And how does the leader become aware of a high rate of deviance from procedures, and what would you recommend to a leader to sort of unearth that problem and how to approach remedying it?
That's a very good question. How do leaders become aware? That's one of the very fundamental roles of a near-miss reporting program. So if the people who do it, live it, and breathe it every day, if one of their reports is, I did it according to the regulation and almost had a problem, so therefore I did it contrary to the regulation, that kind of reporting from the front lines, because I guarantee the front lines, they know better than anybody in the system what's working well, what's not working well, and they probably also have some very good ideas on how to improve the things that aren't working well. So that would be a source of, but it's also a source if OSHA shows up and says you're not complying with this rule or that rule, and if you see a lot of that and it's happened over the years, then that's when you see for a long-standing non-compliance, that's what some of the writers call normalization of deviance, and it's not a good thing. The reason it's not a good thing is because there is a disconnect between what the people are doing and what the rules say they should be doing. There should not be that disconnect. So the question is it because we got bad people? And if you do have bad people, then I'm first in line to say get rid of them. Or do you have good people trying to do it better, faster, cheaper, but the rule isn't quite right? So there are lots of ways to find that out, but a near-miss reporting system is certainly one of the ways. Hopefully you find it out from that before you find it out from your regulator. But that certainly is a way to find it out, is by a reporting system that says I did it according to the rule, almost had a oops, did it another way, worked better, et cetera, et cetera. So that it's very important to have a robust reporting system so that the people up top don't have the General Motors thing where the bad news never reaches the top.
Okay, any other questions? Shelley has one coming in from the webcast, so if you'll give me just a second to get in there. You know, one of the things that we've struggled with too while I wait for this question is, you know, how do you adapt something like this? Thank you. How do you adapt something like this to operators of varying sizes? I know in the aviation world, you know, you're dominated by some very large players, but in the pipeline world, there's some very small players, and then also some very large players. So I know the committee wrestled with that tirelessly. And I think the reason that we wrestled with it so much is so many obsess on the compliance aspect. And while Linda said we don't intend, anytime real soon to make it a regulation, we see it as the right answer. We're trying to help here. There are some who will say, well, even if it's not you, a court of law will say it's a standard, and therefore we should have been following it regardless of our size. So I don't know if you guys struggled with that at all with small players.
That's a good question, and I probably don't have a good answer because my experience is based on a small number of big players. We don't have a lot of small players. That actually goes in part to Linda's question too about how do you get the non-compliance to join the party, so to speak. And I don't have a real good answer for that because I don't have an experiential basis for answering that because that's not our experience. But that's a fair question, and hopefully they too will see the benefit of doing the collaborative thing so that it not only makes them safer but improves their bottom line as well.
And I think to your point, we did invite in our first workshop, Armando Martinez. If some of you may remember him from that workshop, he is one of the senior guys at Miami Air, but very small. And Armando, I thought, very eloquently made the point that he actually made money on it. It wasn't, his productivity did jump. He was able to hire somebody else to help him. He had done so well on this, on the return on his investment. So while he was skeptical at first, so your point early on, I think Armando made a really good case. That is on YouTube if you want to watch it, anyone. So the question that came in from the webcast was from Gary at Equitable. Hey, Gary. Question had to do with operator qualifications, and Gary was pointing out that was a collaborative process, but it wasn't well received by many, and what were the lessons learned? I don't know that that's a fair question for you as much as it might be for us, but you're welcome to swing at it. We had a negotiated rulemaking some time ago, and I think that's one thing that sets it apart from what we're talking about. That was a negotiated rulemaking to establish compliance levels. And I'm not so sure about the assessment about it not working well. I think there were many things in operator qualification that did benefit.
I'm not sure I understand the reference to operator qualification. Can you help me with that?
We established a negotiated rulemaking to set qualification requirements for people who were operating and actually physically working on the pipeline. And so I think it was a good experiment at the time. People decided rather than the regulator go off in its corner and think up what they think should be done and throw it out there, we entered into negotiated rulemaking. And so I think in there, the difference there was I think that everyone saw compliance as the outcome, as opposed to performance. And so they're coming in great. So I don't know that that's a fair one for you. I think it was really a sort of a regulatory one. Here's one from Christy Murray, someone we all know well. She said, you mentioned SMS could be used in various industries. Have you seen regulators apply the system think model internally within their federal agencies? If so, could you provide an example?
That's a very good question. And it's interesting, for example, in aviation that the international, if you will, the international regulator, it's actually the aviation organ of the United Nations, which is called ICAO, International Civil Aviation Organization. They mandated safety management systems for airports. They mandated them for manufacturers. They mandated them for operators. Strangely enough, they didn't mandate them for regulators. So kind of like, again, I'm okay, you're not. So the answer is, I have seen some regulators start to do that, but they're kind of late in the parade, relatively speaking, because it's kind of, that's the same thing, I'm okay, you're not. So you need a safety management system, I don't. So I am starting to see a move in that direction, but it is slow to be sure, slow at best.
Right. Any other questions for Chris? Andy?
Chris Hart, it's good to see you. My
Thank you.
name's Andy
Good to see
Drake
you.
with Spectre Energy. I hear your challenge to us. I guess I have a question that just sort of hit me with your comment, and that is, this standard is really being developed with more of an intent, I think, to be applied to operators. How successful do you think we will be in our bigger charge of driving pipeline safety incidents down if it stays only applied to pipeline safety operators and isn't embraced on this bigger scale that you talk about with the FAA?
That's a good question. I would suggest to you that this application to operators could be a good starting point for a broader application. And that's why I'm saying crawl, walk, run is what I would recommend, as opposed to, you know, starting at this industry level. I don't see a lot of industries that can start at the industry level the way we did. And that's why I suggest starting at a more of a crawl, walk, run type approach than go for the whole 9 yards. So I would see this as assuming it's successful because of the collaboration is done appropriately. And what we saw in aviation was, in order to make it successful, we needed progressive leaders in two important places. One was in the industry and one was with the regulator. And we were lucky to have both of those at the same time to help push that. And I'm seeing some progressive leadership already just from what I've heard about this effort. So I think this could be a foundational effort to be used as an example for others to look to how to broaden it.
Okay, I think last question we'll take, and just want to be respectful of the people who are participating via webcast. Gary out there, I'm still struggling with myself on this one, Chris, so feel free to punt. But the comment says that deviation from compliance versus deviation from procedures is the topic. One is a regulatory issue, but still a problem. Can you comment?
Well, I guess when I'm thinking of compliance, I'm thinking of compliance with a procedure that was established by whoever. It could be by the regulator, could be by the operator, could be by whatever level. I'm talking about deviation from the way the book says to do it, whatever that book might be. And to the extent there is deviation from the book, whoever invented that, because the chances are that whoever wrote the book is not an operator, not a hands-on operator. If there's deviation between the way it really works and the way the book says it should work, that's a problem. And that problem needs to be addressed, because you want to discourage deviation, but not discourage it by punishing people who deviate. If these are good people who are doing it better, faster, cheaper, then that's a huge red flag to look at whether the book is written in the way that responds to the situation. And we've seen many of those in aviation where the book didn't work right. So an example I give oftentimes is that when United Airlines, and I'm not speaking out of school by using names because they were all through the trade press about this, when they started looking at flight data recorders routinely, they started noticing a lot of situations where the pilots were putting the flaps down too fast. So the flaps are the surface on the trailing edge of the wing that come down for takeoff and landing, and the purpose of the flaps is so that you can fly slower, and the purpose of being able to fly slower is so that you need less runway to take off and land. But when the flaps are out, the wings are less robust. So because of that, there's a speed limit on use of the flaps. Do not use the flaps above 250 knots. I'm just picking a number. Okay, if you use flaps above 280 knots, you have so exceeded the maximum speed for flaps that you may have breached the structural integrity of the wing. So one of the first things they noticed when they started looking at flight data recorders was numerous instances, and that, by the way, that's called a maintenance event flap over speed, because when there's a possible breach of integrity, then this airplane has to come off the line for 3 whole days, major disassembly, inspection, reassembly, to see if the structure was breached. So the head of safety at United went to the pilots, noticing in the flight data recorders numerous instances of not only flap over speeds, but maintenance event flap over speed. Two questions, two points to the pilots. Number 1 point, I will not punish you with what you tell me. Number 2, why are you putting the flaps down too fast? So they said, well, that's easy, because the air traffic controllers are bringing us in too high and too fast, and we have to do something to get rid of all that energy, or we will not be able to do the landing successfully the first time, because we're going too high and too fast. Then we have to go around, do an aborted landing. Now it's more work for the controllers, more time on the airplane, more fuel burn, upset passengers, et cetera, et cetera. A huge, huge lose-lose. But they are putting the flaps down too fast because they're trying to do the right thing and get the landing done the first time. So, progressive thinker that he was, he went to the FAA, who employs the controllers, who tell the pilots what to do, and they said, your controllers are putting my pilots in a situation where they have to do what they should not do in order to complete the landing successfully the first time. In other words, he realized this is a system problem and not a pilot problem. So he addressed it as a system problem and not a pilot problem. Found out that these approaches were great for DC-4s and DC-6s, not so hot for 737s. And they were just out of date, had not been revised in a whole bunch of years. So they revised the approaches, bottom line, reduced maintenance event flap over speeds by 90% in less than a year. Wow, that's when I realized, boy, there's not only a safety benefit, but a huge, huge productivity benefit by not taking these $100 and $200 million airplanes off the line for 3 whole days, disassemble, inspect, reassemble, because they reduced flap over speeds, maintenance event flap over speeds by 90%. So these pilots were not complying with the book and even creating potential hazards because they could breach the structural integrity of the airplane, but they were trying to get the job done right the first time. They weren't bad people that didn't like rules. They were good people trying to do it better, faster, cheaper, and what it showed them was that the way that they were being led into the system by the controllers was creating this dilemma for them, and their solution for the dilemma was, we'll put the flaps down too fast. So that was such a huge success story that showed, yes, these are people who aren't doing what they're supposed to do, and you don't want people not doing what they're supposed to do. You need to fix that and eliminate that disparity between what the book says and what the people are actually doing.
If it wasn't obvious to you before, Chris has a commercial pilot's license, so it is pretty deep on this area, on the aviation. Chris, I want to thank you. To Gary, my only thing that I would add to that, I'm just trying to be responsive to people on the webcast, is I think that that's a good example of where we talk about focusing on compliance with the regulation versus focusing on getting a solution that really works. The regulation is always going to be the minimum that's required, but certainly not what's needed in all cases. It's the minimum that could be established through that negotiated process. So with that, I hope you'll join me in thanking Chris Hart for talking to us this morning.
My pleasure.